Beneath the breathtaking vistas of Yellowstone, past the herds of bison and the winding rivers, a colossal heart beats. It's a rhythm not of muscle and blood, but of magma and steam. We see its breath in the misty columns of Old Faithful. We hear its growl in the gurgling mud pots. But what we see on the surface is just a whisper of the immense power churning deep within the earth. Today, we're journeying into the fiery core of America's first national park to uncover a secret hidden in plain sight, a volcanic system of unimaginable scale, and we'll explore the delicate balance it maintains between spectacular creation and potential devastation. For millions of visitors, Yellowstone is a postcard come to life. Geysers like Old Faithful perform on a schedule, a seemingly tame and predictable display of nature's plumbing. We marvel at the vibrant, otherworldly colors of the grand prismatic spring, painted by heat-loving microbes. We watch the landscape steam and hiss, a constant reminder that something is happening just below our feet. This is the hydrothermal system, Yellowstone's famous calling card. Think of it as the exhaust system for a gigantic underground engine. Rainwater and snowmelt seep deep into the ground, sometimes for miles, through a network of cracks and fissures. Down there, it approaches the immense heat source, a massive chamber of partially molten rock, the magma chamber of the Yellowstone supervolcano. Heated to incredible temperatures far beyond boiling point, the water is put under immense pressure. It wants to flash into steam, but the weight of the rock above keeps it liquid. This superheated water is less dense, so it races back towards the surface, dissolving minerals from the rock as it goes. When it finally finds a path to the open air, the pressure is instantly released. The water explodes into steam, creating the spectacular eruptions we know as geysers. The colorful pools and terraces, they are formed by the minerals that were dissolved in that hot water, deposited layer by layer as the water cools. It's a magnificent dynamic process, a geological masterpiece painted over millennia. But this beautiful system is also a safety valve. It's constantly releasing heat and pressure from the volcanic beast below, preventing it from building up to a critical point. But this raises a chilling question. What if the plumbing gets clogged? What if the pressure can't be released? This is the dual nature of Yellowstone's fiery heart. It's both a life-giving source of wonder and a ticking clock. To truly understand the scale of what's happening, we need to peel back the layers of the earth. We're not talking about a typical cone-shaped volcano like Mount St. Helens. Yellowstone is a caldera, which is essentially a massive crater left behind by a previous super-eruption. The last one happened about 640,000 years ago, and it was an event that reshaped the continent. The eruption was so colossal that the ground collapsed into the now empty magma chamber, forming the vast basin that is the Yellowstone caldera, stretching nearly 45 miles across. The magma chamber that fed that eruption is still there, lurking just a few miles beneath the park's surface. And it is enormous. Imagine a molten reservoir big enough to fill the Grand Canyon more than 11 times over. That's the engine driving every geyser and every hot spring. Scientists use an incredible array of tools to keep a finger on this giant's pulse. A network of seismometers across the park listens for the faintest of earth tremors. Even the slightest earthquake can indicate magma shifting or fluids moving underground. They also use GPS stations to measure ground deformation. As the magma chamber swells with new material from the Earth's mantle, or as the hydrothermal fluids shift, the ground above can rise and fall. We're talking about changes of just a few inches a year, but over the vast area of the caldera, it represents a massive volume change. It's like watching a giant breathe, in and out, over a timescale of years and decades. Satellite radar and gas sensors that sniff the air for volcanic gases like sulfur dioxide and carbon dioxide add even more layers to this complex monitoring system. Every piece of data is a clue, helping scientists build a picture of the activity happening in the unseen depths. So, what are these instruments telling us? Well, Yellowstone is very much alive. The ground is constantly rising and falling. The park experiences thousands of earthquakes each year, though most are too small for anyone to feel. In 2017, for instance, a swarm of over 2,400 earthquakes occurred over several months near Maple Creek. While this sounds alarming, Geologists tell us this is normal behavior for Yellowstone. These earthquake swarms are often caused by the movement of water and gas through the complex underground fracture network, not necessarily by rising magma. It's the system adjusting itself, creaking and groaning like an old house. The ground has gone through periods of both uplift and subsidence. From 2004 to 2010, the caldera floor rose at a record rate of about 3 inches per year. Then, it started to fall again. This isn't necessarily a sign of an impending eruption, but rather the dynamic interplay of magma and the hydrothermal system. It's a complex breathing system, and these fluctuations are its normal rhythm. This brings us to the big question, the one on everyone's mind. When will it blow again? Based on the last 3 major eruptions, 2.1 million, 1.3 million, and 640,000 years ago, some people have calculated a rough average cycle of about 600,000 to 800,000 years. By that math, we might seem due. But volcanoes don't run on a simple schedule like a train. That's not how geology works. The United States Geological Survey, the authority on this, puts the yearly probability of another caldera-forming eruption at about 1 in 730,000. To put that in perspective, you have a much, much higher chance of being struck by lightning. Scientists stress that before any such cataclysmic event, there would be clear and dramatic warning signs for weeks, months, or even years beforehand. We're talking about intense earthquake swarms that would be felt by everyone, rapid and large-scale ground deformation, and massive changes in the geyser and hot spring activity. The system would practically be screaming that something was wrong. Right now, it's just humming along. In fact, the most likely eruption at Yellowstone isn't a super-eruption at all. Far more probable are hydrothermal explosions or smaller lava flows. Hydrothermal explosions happen when the underground steam system gets blocked and pressure builds to a breaking point. They can be violent, hurling mud, rock, and boiling water hundreds of feet, leaving behind craters. These have happened many times in Yellowstone's recent geological past. The other possibility is a lava flow. Since the last super-eruption, there have been about 80 smaller, non-explosive eruptions of thick, slow-moving rheolitic lava. The most recent was about 70,000 years ago. An event like this today would be significant and destructive within the park, but its effects would be localized, nothing like the continent-altering super-eruption scenario. This is the reality of the threat. Less about a global catastrophe and more about localized, albeit still dangerous, geological events. So we can all breathe a little easier. The fiery heart of Yellowstone is not a doomsday clock poised at midnight. Instead, it's a testament to the incredible living forces that shape our planet. It's a dynamic, breathing entity that creates as much as it has the potential to destroy. The geysers and hot springs aren't just tourist attractions. They are the vital signs of a sleeping giant, monitored around the clock by dedicated scientists. They remind us that the ground beneath our feet is not static, but a place of constant change and immense power. The beauty of Yellowstone is inseparable from its volcanic nature. One cannot exist without the other. The same heat that fuels the geysers also sustains a unique ecosystem found nowhere else on Earth. Visiting Yellowstone is more than just a vacation. It's a journey to the heart of a geological wonder. It's a chance to witness the raw power of our planet in real time. So the next time you see Old Faithful erupt, or gaze into the vibrant depths of the Grand Prismatic Spring, remember the colossal engine working tirelessly beneath the surface. Don't see it with fear, but with awe and respect for the magnificent fiery heartbeat of our world. Thank you so much for joining me on this deep dive into Yellowstone's geology. If you found this journey as fascinating as I did, please give this video a thumbs up and consider subscribing to the channel for more explorations into the wonders of our planet. Don't forget to hit that notification bell so you won't miss our next adventure. Until next time, stay curious.